Welcome to a lesson on exercise 7G. It is 2:29. I'm not sure why no one is here, but I'll record the lesson so anyone who wants to do it afterwards can do so. Okay, so we're doing 7G today. 7G is about applying similar triangles. Now, yesterday we did similar triangles, and a very quick revision of yesterday. Similar triangles are triangles which are very similar to each other, but they are not identical. Why are they not identical? Because one of them is a bigger or smaller version of the other. Um, so one of them is a bigger or smaller version of the other. So in this, for example, we might have something like this. And obviously I'm doing it by hand, so it might not be 100% perfect, but you get the idea. Now, in the similar triangles, the angles are the same. Corresponding angles are equal. So for example, if I said that's 30 and the corresponding angle to that is this one, then this will also be 30. And if that was, let's say, 80, then that would also be 80, as long as that was the corresponding angle. By corresponding angle, I mean like if you were to enlarge this figure, what would this angle become? And it would become that angle there. So it's like the corresponding angle. And finally, 30, 80, 170. So this would be 70, and that would be 70. So angles are exactly the same. And the second feature of similar triangles is that their sides are in ratio. So for example, and all the sides are in the same ratio. That's important to understand. So for example, if this is 5 and this is 10, then we can see that corresponding sides are in ratio. We can see that if that's 5 and this is 10, then this is twice as big. That triangle is twice as big, so to speak, as this triangle. The sides are twice as big. All the sides are twice as big as their matching sides in the other triangle. So if I then said to you, what this is 4, then what's the matching side here? And we could say, because all the sides are twice as big in the second triangle, we would say, this is 8. And that's generally the gist of what we're doing today. It's actually finding out these values using similar triangles to solve problems. So let's get started. A homemade raft consists of 2 sails with measurements and angles as shown in this diagram. Explain why the 2 sails are similar in shape. So first of all, how do we know that this triangle is similar to that triangle? How do we know? Well, thinking about yesterday, there were a few tests, but for the time being, let's just see RHS, it seems to me, or equiangular, actually, it would be the test here, the correct test, because they're similar because we can see that this angle and this angle are the same. So we have an A, and you also have a right angle. And so you have 2 angles, in other words, 3 angles, which are equal. And therefore, we can say for sure that this is these 2 triangles are similar. And explain why the 2 sails are similar in shape. They're similar because they are equiangular. They're similar because they are equiangular. Okay, and then we move on to part B. It says find the scale factor for the side lengths of the sail. Scale factor means how much bigger, by what do you have to multiply the sides on the first triangle to get the second triangle? What's the factor? What do you have to multiply by? What do you have to multiply by? So let's have a look at this. So let's see, between the right angle and that angle is the 2, and between the right angle and that angle is the 5. So the 2 becomes a 5, so to speak. Another way to think of it is we can write this in a ratio. We can write it as a fraction. So it's 5/2. And we are putting the big triangle on the top. Okay, so the scale factor we can say is 5/2. If we put the big triangle on top, 5/2 is just 2.5. So 2.5 is a scale factor. It's 2.5 times as big as 2. 5 is 2.5 times as big as 2. So now we're doing part C, and we're going to use that scale factor, the 2.5. Find the length of the longest side of the large sail. Now, the longest side of the large sail is going to be opposite the biggest angle. And because we have a 90-degree angle, we know that the biggest side is going to be opposite the right angle, the hypotenuse. So we're trying to find this side here. And the corresponding side is obviously 3.5. So x over 3.5 is going to equal to 5/2. Or alternatively, you can solve that. That's what we did yesterday. Or we can use a scale factor here. And scale factor just means, remember we said that the larger side is 2.5 times as big as the smaller side? Well, if the smaller side is 3.5, we can use 3.5. We just multiply by 2.5. And we're done. And that will be what? 8.75, I believe. 8.75 meters. And that's it. Or you can do it what we did yesterday. Which is that way. Set up a relationship, set up the ratio, the sides are going to be in ratio. So we set up the ratio relationship, and then we solve it. Or to use a scale factor, you calculate the scale factor, you find out how many times bigger the side of one triangle is as compared to the other, and then use that number, however many times it is bigger. You can use it for any of the other sides to find the equivalent side in the second triangle. So let's have a look at a second question. Another worked example. A ramp is supported by a vertical stud, AB. Okay, so we have AB there, where A is at the center of CD. All right, so that seems to be important. Where A is at the center of CD. A is at the center. So that's 6, and this is going to be 3, and that's going to be 3. That's not marked, so I'm going to mark it in now. It is known that CD is 6. Yeah, that's marked. And that the ramp is 3 meters high. That's marked as well. Fair enough. Using that as given, name the two triangles that are similar and explain why. Okay, well, there are only 2 triangles. So, okay, so in case you can't see, I'll just highlight it in yellow. That's the first triangle, right? Hopefully you can see that triangle. And then you also have the big triangle here. That big triangle there. All right, and they're going to be similar. Why? Well, for starters, we know that this is a common angle. This angle is in both triangles, and then we also know that that is a right angle triangle there and a right angle triangle there. So it's equiangular. 2 angles, or 3 angles rather. I can do it the same. I mean, yeah. So using that as given, name the 2 angles that are similar and explain why. Using the letters given. So let's do CAB. We're doing triangle CAB, we're doing part A, is similar to triangle CDE. CAB, CDE, CDE. And then we can simply write equiangular. And hopefully you can see why they are similar, equiangular. And if you wanted to give more information, you could say angle, and depending on the wording of the question, in my opinion, part A is done, is fine, we've answered it. But if you had to explain, give complete reasons, then we'd write angle, we'd write on top of this. So this down, and then we would write angle BCA is equal to angle ECD. And the reason is common. That angle is common. And then we could also write CAB is equal to CAB and CDE. And both of them are 90 degrees. Given. We know that 90 because it was given to us, right? And that's it, we're done. And then we just write, therefore, CAB is similar to angular triangle CDE because they're equiangular. All right, moving on to part B, which is today. Find the length of the stud AB. So we are trying to find AB here. And I'll just clear it up a bit, just so we can see a bit clearer. Okay, so, and often, actually, it helps to draw the two triangles. We are dealing with two different triangles. So what I'm going to do is I'm going to draw the small triangle, and then I will draw the big triangle separately. I'm drawing them separately, and that often helps. I know that is 6. I know this is 3. And how high is it? The big triangle is 3 meters high. How high is the small one? We don't know. We are trying to find it out. Okay, and hopefully you can see the. What's we call it? The scale factor. Okay, the scale factor, we can write the big triangle over the small triangle. Any of the side, it has to be corresponding side. Notice that it is the right angles, and the corresponding side is 6 and 3. So 6 over 3 will give us a scale factor of 2. And now that we have 2, we know that all the sides in this triangle are twice as big, 2 times as big as all the corresponding sides over there. And so we know that 2 times x is going to give us 3. 2 times x is going to give us 3. Well, x is therefore 1.5. And we are done. X is 1.5. And I believe that's the last work example. You should be fine giving it a go. And as always, you can ask me for help on Slack if needed. I'm happy to do a Zoom session. I'm a little disappointed that no one turned up today. It's really odd. I would have expected, at least some people to have turned up. But anyway, I'm going to end the recording there, and best of luck with the homework.